In this video, we'll quickly revise the laws of exponents that you have learned in previous grades. The first law that we learned is the law of multiplication, and the law states that if the base values are the same and we multiply them together, then we can add the exponents. So let us say, for example, we have x squared and we want to multiply it with x to the power of 9. In order to simplify that, we would say this is equals to x to the power of 2 plus 9, and that is equals to x to the power of 11. Another example would be if we have x squared, y to the power of 3, x to the power of 4, y to the power of 7. Now, we can only add up the exponents of the variables that are the same. So, in this example, we'll have x to the power of 2 plus 4 times y to the power of 3 plus 7. So if I simplify, this will be x to the power of 6 and y to the power of 10. So the law is important. In order to add the exponents together, the base values or the base variables must be the same. The second law says if the base values are the same and we divide two values with one another, then we can subtract exponents. So for example, if I have x to the power of 6 divided by x to the power of 2, it will be the same as saying x to the power of 6 minus 2, and that simplifies to x to the power of 4. Another example would be if I have p to the power of 10, q to the power of 7, divided by p to the power of 4, q to the power of 2. Now, in order to apply the law of exponents here, we would say this is p to the power of 10 minus 4 times q to the power of 7 minus 2. And that simplifies to p to the power of 6 times q to the power of 5. The third law of exponents is that if I have something raised to the power and I have that in brackets and I raise the bracket to another power, then I can multiply the exponents together. So let's say we have x squared raised to the power of 3. And this will be the same as saying x to the power of 2 times 3, which becomes x to the power of 6. Now the next law builds on the previous one. Let's say I have a to the power of n, b to the power of m, and I raise this to the power of p. What this law says that I can multiply each of the exponents on the inside of the bracket with the exponent on the outside of the bracket. So this will be a to the power of np, b to the power of mp. Let me show you a quick example. Let's say we have x cubed, y squared, and we want to raise this to the power of 4. This would be the same as saying x to the power of 3 times 4, because I multiply the 4 with the 3. Y to the power of 2 times 4, because I multiply the 4 with the 2. And that simplifies to x to the power of 12, y to the power of 8. And the next law that we learned builds on the previous two. So let's say we have a to the power of n over b to the power of m, and I raise this to the power of p. Then now what I would do is I would distribute the outside exponent to the inside exponent. So I will have a to the power of np over b to the power of mp. Let me show you an example. Let's say we have x cubed over y squared raised to the power of 4. Now I'll multiply 3 with 4 and I'll multiply 2 with 4. So this would be x to the power of 3 times 4 over y to the power of 2 times 4. And this becomes x to the power of 12 over y to the power of 8. Other properties of exponents are, for example, if I have the square root raised to the power of n of a certain value, that will be the same as saying a to the power of 1 over n. So if I have the square root of x to the power of 3, that will be the same as saying x to the power of 3 over 2. Or if I have the cube root of y to the power of 1, or just y, that would be the same as saying y to the power of 1 over 3. So in case of the square root, the value inside of the root is 2, and we'll divide the exponent on the inside with 2. And in the cube root, we'll divide the exponent on the inside with 3. And this would be valid for any other form. So let's say, for example, we have the root form of 4, and we have x squared and y to the power of 3. So if I want to remove the root, this can become x to the power of 2 over 4 times y to the power of 3 over 4. And I can simplify the exponent of x. So that becomes x to the power of a half times y to the power of 3 over 4. But notice that I divided the exponent on the inside with the root form on the outside. Other properties that we have learned is anything raised to the power of 0 is equals to 1. And if I have a to the power of negative 1, that's the same as saying 1 over a. So if I have x to the power of negative 2, that would be the same as saying 1 over x squared. And if I have, for example, 1 over a to the power of negative 1, that would be a to the power of 1. So let's say, for example, I have 1 over y to the power of negative 3. That becomes y to the power of 3. So what we see is when we have a negative, that creates a fraction. I could write 1 over the variable to make the exponent positive. So in this example, we had x to the power of negative 2. And I write 1 over it, so it becomes x squared. And that's how I make the exponent positive. And the reason why we need to be able to do this is in algebra, we always want to leave our answers in positive exponents.